come to the TCF. Every year they say this will be the last one. We hope this is not the last one. My name is Lewart. You see my email there. I have about 50 slides, but I won't go into too much details on the slides, otherwise it's more than an hour. So if you send me an email to this address, lewart@manmus.com, in a day or two I will send you a copy of all my slides. So that's all the details. You know that this is my business card. I show my coordinates so people can find me. It's a good idea. I also put the coordinates of my house on my email returns. I gave a similar talk at the Hackers Convention in New York a couple of years ago on Hope, Hackers of Planet Earth. It was similar, sort of geared more towards hacking, and I called it Hack Your GPS. But this is sort of more civil version of the same talk. Okay, next. All right, here's the talk outline. I will give you the basics of the system, of the GPS system. I will talk. The second line is about the most important one in my talk: finding your location on the globe. This is my own approach. Okay. Does it work fine? Okay. So now we'll talk about the privacy issues. We'll tell you about the various kinds of GPS and what we can expect in the future. Next.
Haiku.
Here are some haiku verses. I like in particular the last one. Batteries are toast. Never learn to use map or compass. Await rescue. Whatever you do with the GPS, learn how to use the map and learn how to use the compass. Because one of the important features of the GPS is that you have to move. If you stand, you will get the location, but you don't know which way is north, which way is south. You don't have a compass, unless it's a kind of GPS which also has an electronic compass, which has to be calibrated every few days. Next.
Basic GPS.
It's a basic GPS design. GPS was developed by the Department of Defense about 25 years ago. Originally, it was meant to be used just by the military. However, in later years, it became more and more popular for the civilian use. And today, I think probably 99% of its use is civilian use. There are 24 satellites in 6 orbits in 12-hour cycles. So every 12 hours, the thing turns around and comes back. And they are around 20. For a 12-hour orbit, the orbit time and the height about the Earth are related by Kepler's and Newtonian laws. So for 12 hours, they circle it around 20,000 kilometers about the Earth. In addition to the DoD satellites, there's also GLONASS developed by the Russian Republic, while the GPS satellites are in circular orbits. The GLONASS satellites are in more elliptical orbits, so they spend more time over the Soviet Union, over fellow Russian federations, and over the rest of the Earth. There's also a system developed by the Europeans who don't want to be dependent on DoD or the Russians, and it's called Galileo, and still in the experimental stage. So they need cooperation of various countries in Europe to make it work. So it's still temporary. So the only currently working two systems are the Russian one, GLONASS, and the American one, GPS. Because most of the civilian uses for GPS, I know the GLONASS people give the receiver to Putin's dog, so he can find the dog. But they don't have too many reasonably priced receivers on the market. With the American development of civilian receivers, they're now down into, and the basic chips are just a few dollars, so you can incorporate it in various devices, and the complete GPS starts from $100 to $300-400. Next.
It's the orbits.
This is more or less the scale. So you can see that there are six planes. In each one you have 4 satellites. So you see the size of the Earth and the size of the orbits. So with this arrangement, you have at least 4 satellites always inside. Because as they transmit on quite high frequency, it's always line of sight. The frequency would not pass through the Earth. So you have between 4 and 7 satellites at any time, at any place on Earth, from North Pole to South Pole, and anywhere in between. Next. Here you have an artisan rendition of a GPS satellite. Uses solar panels and has extremely precise clocks. We'll talk about it a little later. How the clocks are being used for determining where you are on the globe. Next. Now the operating modes, you have the mode for which it was originally designed, the precision mode, which is used by the military and allies, and it requires receivers which you also need special codes which are changed every day. So they cannot be used by civilians. The big advantage of the precision mode used by the military and the government agency is that it's resistant to jamming. It's originally, when the system was developed, they didn't want non-American military to be able to pinpoint on various targets. So there was something called selective availability built into the system, which degraded the system so you could have like 100-meter precision, whereas a military system had like 20-meter precision. In 1960, in the year 2000, May 1st, President Clinton decided it makes no sense. Let's drop it. If somebody wants to drop a bomb on us, they will find the place anyway. So they dropped the selective availability. So now the civilian system is about as precise as the military system. So the main difference is that the military system is more resistant to jamming.
This is not the same.
Yeah. You also have, for surveying, you can also get a very precise indication where you are by running your reading for maybe 5-10 minutes and averaging your results. So with this system, which is used for land surveys, you can get within a few centimeters, so within an inch or even better. So these are the basic modes. The military modes, the civilian mode, the survey modes, and the differential mode, which is not in much use today. Next. Yeah. This is the most important part of my talk. If you learn this, you can forget all the rest. There are very precise clocks on the satellites. I mean, there are rubidium and cesium clocks, which are adjusted by the Department of Defense every day, every few hours. So you have precision like 1 second in 300 years. And so when you have your receiver, whether it's portable or in your car, you talk to the satellites inside, and the satellite will tell you it's 10 o'clock and 1 second, let's say, and I'm satellite number 1. Now you check with your receiver, and your receiver says, now it's 10 o'clock and 1 second and and 20 milliseconds, which means you can assume that it took 20 milliseconds to get from the satellite to your receiver. In addition to the clock information from each satellite, you also get 2 pieces which are sent every few minutes. One is called almanac and one is called ephemeris. Almanac information, which is the same being sent from each satellite, tells you what's the condition of the satellite, whether it's operating, whether its clock is correct, etc. The ephemeris tells you where the satellite is at a specific moment. And those of you who are familiar with astronomy, you know, ephemeris gives you exact information when a star goes up over the horizon, when it goes down. So from those 2 pieces from the almanac and the ephemeris, you know exactly where the satellite should be in the air at a specific moment. Okay, now I give a specific example. This is something you won't find, and I developed it myself, because when everybody is telling, well, it just talks to satellites, and that's how you get your position. I figured out what's an easy way to explain how it works. So I made a simplified 2-dimensional model, assuming one satellite is at one end, one side, and one satellite is on the, let's say, east, one is west of you, and you are in the middle somewhere. And now you check your distance from your satellite by measuring the difference in time between the information you get from the satellite and your clock. And you can actually get into the vocabulary of the GPS, and my cousin of mine just modified it, like instead of saying recalculating, said, shit, you lost your way. Try again. There are also some specially developed GPS, like we do a lot of geocaching, which I will mention later. This one is specifically designed for geocaching.
Secret keystrokes.
Yeah, here are the secret keystrokes. I had a Magellan, portable Magellan, so you call it this and this and press that, and there's a little window opening, and you have to enter a certain number in this window. Because if you do it wrong, you screw up completely your unit. So make sure you know what you are doing.